Okay, welcome everyone. It's my pleasure to talk to you about another topic in infectious disease for our podcast site. I'm Richard Oehler, Associate Professor of Medicine, and I'm going to talk with you today about another facet of the climate crisis. Most Americans now seem resigned to the fact that climate change will have wide-ranging effects on us and the Earth. We know some of the major ones, of course, from the melting of the polar ice caps to the rising of the world's oceans and so forth. But the question we're going to discuss today is, what is the effect global warming is likely to have on human disease? How will climate change affect infectious diseases? Now, many people associate our recognition of the significance of climate change with the release of a movie called An Inconvenient Truth in 2005. How many of you here in the auditorium saw that movie? Okay. I highly recommend it. Truthfully, though, our awareness that we could affect the Earth's climate dates back far longer. About 150 years longer, to be precise. In 1859, this man was born, and also resulted in the publication of a seminal work in science. Does anyone know who this man is? This was Svante Arrhenius. We owe the modern theory of global warming to Dr. Arrhenius, the Swedish scientist who first developed a theory to explain the ice ages and who first speculated that the level of carbon dioxide in the atmosphere could substantially alter surface temperatures through the greenhouse effect. So remember this, if for anything, if you ever appear on Who Wants to Be a Millionaire. Now, 1859 also marked the date of publication of this work on the origin of the species, Charles Darwin's landmark work that paved the way for the development of the field of evolutionary biology. Now, central to Darwin's work and inherent in the theories of Arrhenius is the principle of adaptation. You may have heard about this or learned about it in college or in your previous learning, of course. And we all know that adaptation is an alteration in behavior, habits, or function by which an organism improves its survivability in a changing environment. Now, we see countless examples of adaptation in the biological world. Look at this organism. You can easily argue that it's adapted to living in places where there are twigs or sticks. How about in the long tapered neck of a giraffe, adapted to being able to feed on tall trees? And I'm sure that we can all recognize that a duck is better adapted to paddle and float on its environment than, let's say, we are, especially me. I can't swim. Now, in truth, global warming is occurring because of the adaptation that we have made to our environment, whether it involves our need to travel or to remain comfortable or to shape our world around us. The common equation is carbon. And because of our human activities, especially over the last 150 years, we have begun to change the carbon balance in our air. The Earth, in turn, is adapting, perhaps for the first time, to us by retaining more heat within the atmosphere. Now, we see countless examples of adaptation in the microbial world as well. A great example is this strain of Enterococcus faecalis, which has adapted itself to thrive only in the presence of vancomycin. So this strain has become so adapted, it loves to live in vancomycin environments. So adaptation occurs on multiple levels, in the microbial world, in the human world, and on a planetary scale. And we're all scientists here in the room, and probably most of you in this room then know more about climate change than, let's say, the average layperson, because you probably read about it or heard about it as part of being a scientist at heart. But for those who haven't, here's a primer. Much of the radiation emitted by the sun is reflected back into space. The fraction that is retained warms our planet just enough to keep life on Earth livable. Our human activities are changing the balance of carbon dioxide in the air. This blankets our planet and causes more of the heat to be retained. And the long-term effect of this, of course, is that our planet is warming. Now, as Al Gore pointed out in the first portion of his movie An Inconvenient Truth 4 years ago, CO2 levels for much of the last 600,000 years never exceeded about 270 parts per million. Now today, they are at 380 parts per million. And within 45 years, if we do not make dramatic changes in our carbon footprint, they will exceed 600 parts per million, an astounding increase far above where they have ever been in recorded history. And as you can see, Earth's mean temperatures have closely mimicked or followed the mean CO2 measurements. But there have been many skeptics about the significance of CO2 levels, or even if global warming is occurring, because so much of the evidence is either rooted in remote history or has not occurred yet because of the timescales involved. But I think that we should heed the words of James A. Garfield, this man, Civil War general and perhaps the first great president after Reconstruction, who wrote, "History is philosophy teaching by example, and also warning. Its two eyes are geography and chronology." Now, public acceptance of the significance of global climate change has occurred slowly. We know this, but the recognition of global warming as a factor in public health and infectious diseases has been even slower. There were a few insightful publications published in the mid-1990s, but perhaps the first major outbreak attributed to climate change was not documented until as recently as 2004. That year, the Alaska Department of Environmental Conservation notified Alaska public health authorities of several cases of gastroenteritis among passengers on a cruise ship that was sailing in Prince William Sound. Very scenic area. How many of you have been to Alaska? Beautiful area. Now, that may have been. A sick passenger on the cruise ship reported having consumed raw oysters served on board the day prior to the onset of the illness. Now, after an extensive investigation, including a retrospective cohort study, active surveillance, and an environmental study, public health authorities concluded that there was a large outbreak of Vibrio Parahaemolyticus. Now, this outbreak was published in the New England Journal in 2005. But why had it occurred? It had long been known that Alaskan waters were too cold to support sufficient levels of Vibrio Parahaemolyticus to cause disease. But investigators were able to obtain consistent water temperature data from the beds where the ship's oysters were harvested, as well as other data from the Gulf of Alaska. And they ultimately reached two conclusions. Number one, that there had been a trend towards rising temperatures, both at the oyster harvest site in Prince William Sound and in the Gulf of Alaska. And number two, that a mean water temperature of 15 degrees C was necessary to support the growth of Vibrio Parahaemolyticus. And if you look at this graph, you'll see that that was first consistently reached in 2004. Now, this was one of the largest Parahaemolyticus outbreaks ever recorded in the U.S. The warming of the waters appears to have followed trends around the world and is a reflection of warming oceans induced by climate change. And this gradual warming appears to be permanent. And the oyster beds have had to be moved to deeper waters. Now, scientists state that the Earth's climate is basically like a giant engine for redistributing heat from the equator to the poles. Much more of the sun's energy strikes in the tropics, for example, than at the poles. At the tropics, the sun, of course, is almost always directly overhead as compared with each of the extremes of the Earth's poles. Because of the heat distribution effect, some regions of the Earth are likely to be more greatly affected than others, especially at the northern latitudes. But some areas of the tropics, even where many of the world's infectious diseases occur, are also likely not to be spared. Now, I was naturally curious about the effects of climate change at the middle of the Earth when I traveled to Ecuador in December of 2007. This is a picture as we were flying just south of Cuba. I traveled to Quito, of course, about as close as you can get to the equator. Quito, for those of you who have been there, is a beautiful city of 2.1 million persons nestled in between these majestic volcanoes. Very beautiful. And December, when I got there, was in the middle of the wet season, which is Quito's winter. Here I am at the Middle of the World Monument, just north of Quito, officially marking the location of the equatorial line. And I talked to people there, and again, this is just my experience, but they told me that something strange had been going on with Quito's weather in recent memory. That Quito's winters have been much milder and wetter in the last several years, and that the year I traveled, the rain had extended over a much longer period of time into December than usual. We went to a rose farm where the local grower confirmed this and said it had affected his growing season. But as milder, wetter weather affects equatorial South America, the environmental effects can be far-reaching. It turns out that for the residents of the Andes, much of the natural reservoir of water lies in the volcanic snowmass, the glaciers that top its scenic peaks. Dr. Velez just came back from Colombia, in fact.
Yes. Thank you. I was going to share my experience as far as the weather. I remember last time I went to Medellin, Colombia was 4 years ago. And then I went back this time to Medellin. The weather in Medellin is normally 24 C, no Fahrenheit, but 24 C. And it has been up as high as 30.
Wow.
And then, of course, heavy rains more than before.
And yeah, and as the weather gets warmer, in fact, the glaciers are melting at such a rapid rate, in fact, that scientists predict that all of the glaciers in the tropical Andes will disappear by mid-century. This will leave millions of people without their greatest source of drinking water and also the hydroelectric power that it provides. This was such an issue when we were in Quito, for example, that the government there was planning to basically bore a aqueduct through the volcanic mountains to the east of the city to try to obtain water more from the Amazon region, because they knew that they'd have to plan ahead for someday when perhaps the glacial snowmass was not as big of a source of water as it has once been. And as the Andean glaciers melt with the warmer temperatures, encroachment of mosquitoes, flies, and other infectious diseases has occurred. In fact, several years ago, the first case of malaria was reported in El Alto, Bolivia, located at more than 13,500 feet. This is far above the altitude of many of the largest of the Andean cities, such as Bogota and Quito, home to millions of residents who may someday be susceptible to malaria, where they never have been before. So this is a big issue in the middle of the world, and one that is not likely to abate in the near future. Now, there seems to be several different ways that climate change can spread human disease. These may include the consequences of flooding due to the rising oceans, the presence of greater temperature extremes, the glacial melt of ice packs, the presence of increased tropical activity, and the effects of El Nino. Now, the effects of rising oceans, although they're likely to be gradual, can be potentially devastating, even to us here in Florida. It's been estimated that if Greenland melted or broke up and slipped into the sea, or if half of Greenland melted and half of Antarctica did the same, sea levels worldwide would increase between 18 and 20 feet. Now, the last great example of the effects of ocean level rise was perhaps the 2004 Asian Tsunami. How many of you remember that? Raise your hands. Very good. And this served as a cold reminder of what flooding can do to ocean-locked nations. In addition to the rapid loss of life that occurred with the tidal surge, flooding induced widespread devastation in the nation of Indonesia as well as in several other countries. Now, the Asian tsunami and the experience we've learned from flooding disasters here at home, such as Hurricane Katrina several years ago, suggests that less developed countries in the third world would have the highest susceptibility to flooding induced by global warming. Skin, diarrheal, and respiratory infections would be most common, but outbreaks would tend to reflect the endemic infectious diseases common to a specific region. The most common syndromes, for example, seen in post-tsunami Asia included such diseases as cholera and diarrheal diseases, malaria, and something called tsunami lung, which was necrotizing pneumonia as a result of exposure to the floodwaters. Now here in Florida, we are much more vulnerable than we think. We all know, of course, that Florida is a peninsula surrounded on three sides by water. Now here's what would happen to our state if sea levels rose by between 18 and 20 feet. Now remember, we're right there, and we would go from this to being underwater, unfortunately. And there would much of just a central sliver of Florida would remain, and there would be oceanfront property in Brandon. So those of you who are looking to take advantage of the real estate market, get out there now. Some of you have been really good about planning ahead because your property will be leaping up in the next 10 or 15 years, or several decades at least. So the effects of sea level rise are even more dramatic when you realize that out of the world's top 20 metropolises, 13 are at or near sea level, placing millions of people in places like Bangladesh, Shanghai, and Mumbai directly in the way of climate-induced flooding and the social displacement and infectious diseases that could result. So flooding is a definite threat on the horizon. Now, temperature extremes can also play a significant role in human disease. The last 15 years, as we all know, have been among the hottest on record. And just to give you an example, in 2003, Europe experienced an historic heat wave. France was especially hit hard, with almost 15,000 deaths occurring in that country alone. In some parts of France, temperatures that summer in some cities exceeded 104 degrees Fahrenheit. Now, this isn't a country unaccustomed to dealing with heat. An estimated up to 35,000 people died of heat-related illnesses that summer. The elderly tended to be most affected, and infectious diseases ranked second behind heat-related disorders in relative progression of illness, and were the seventh highest category in relative increase. Now, France's healthcare system, which you all may know is perennially ranked number one in the world, was severely strained by this heat outbreak. Now, there's no question that tropical activity has been a subject of great interest and personal awareness for all of us in the state of Florida. Since 1970, there's been an unprecedented increase in the number of Category 4 and 5 hurricanes. Many scientists agree that global climate change is contributing to this increase. As ocean temperatures rise, hurricanes have more fuel to form and intensify. We've had a relatively mild hurricane season this year, but some of you may remember last year when there was an unprecedented 4 tropical systems active at one time, threatening the state of Florida. Now, this is Hurricane Katrina, of course, passing over the Gulf of Mexico in late August 2005, when water temperatures were unusually warm. The yellow, orange, and red zones highlight areas where the water temperature exceeded 82 degrees. Now, the reason why 82 degrees is significant is this is the temperature required for hurricanes to strengthen. So, a wide swath of the ocean and the Gulf there affected and worthy of hurricane intensification. Now, Hurricane Katrina was a wake-up call for the incredible destructive force that a hurricane can inflict upon an entire region. Those of us who remember it, of course, saw a hurricane literally destroy an entire American city within a few hours. And early on, it was obvious that the stranded residents were facing a huge public health problem. Now, early issues within days of the hurricane included gastrointestinal ailments, staphylococcal skin disease, and other skin conditions, and hygiene issues in the shelters, such as in the Superdome. Identified outbreaks of course, included Vibrio vulnificus, enterotoxigenic E. coli, and norovirus. And other pathogens were also seen, but their relationship to the hurricane was less clear. Remember, of course, that the infectious diseases endemic to a region that's affected by flooding tend to be the ones that break out, not ones that are not likely to be seen in that region under normal circumstances. Now, hurricanes are not likely to lead to, as I said, most to exotic infectious diseases, and there's little risk from outbreaks from decaying bodies, for example. The CDC monitors these, so if we're afflicted by a hurricane in the near future, we can keep these principles in mind. Now, how many of you are familiar with the phenomenon of El Nino? We hear that brought up in the media from time to time. Well, El Nino is a phenomenon that is the strongest naturally occurring source of climate variability around the globe. So normally you have this warm water pattern more in the western Pacific, but under conditions of El Nino, it tends to shift over on a more easterly direction until this big area of warm water sits to the west of Central and South America, particularly Peru and Ecuador. And this alters convection loops at the equator, producing widespread changes to weather patterns. So some places may end up being more associated with drought, and some places may have excessive precipitation such that there are floods. And it's likely that in a warmer world, regions that are strongly affected by El Nino will all have their weather patterns altered. If they're a dry place, they will become even drier, or bone dry. If they're a naturally wet place from El Nino, it's more likely that they will become completely flooded out potentially. So some diseases likely to be affected by El Nino could include some of the tropical diseases such as malaria or dengue fever, but particularly waterborne diseases in areas that are excessively flooded due to El Nino activity. So waterborne disease is one of the three categories of environmentally spread infections which are likely to be affected by climate change. So let's touch upon each of these three areas: waterborne, food-borne, and vector-borne disease individually. Now, there is a direct effect in the likely severity of El Nino towards waterborne disease. Now let's look at some examples of how this has occurred in the past. For instance, childhood diarrheal disease doubled in Lima, Peru during the winter of 97-98 when El Nino increased the ambient temperature to about 5 degrees C above normal. And it's been shown in Bangladesh that cholera has varied with El Nino fluctuations, perhaps due to a bloom of these copepods, which can serve as reservoirs for Vibrio cholera and other enteric pathogens. So ways you might not expect in the ecosystem, things can be affected and can lead to a pattern of increased waterborne disease. Now there's also a direct relationship between ambient temperatures and food-borne infectious diseases. In Europe, for example, 80% of reported cases of salmonellosis are secondary to higher than average temperatures. And whenever it gets hot in the UK, food poisoning cases increase correspondingly. But perhaps the area where climate change is expected to have the most direct effect on transmission is in the area of vector-borne diseases. This is because warmer temperatures increase vectors such as mosquito and tick reproduction, biting, and transmission cycles. And changes in rainfall and humidity may affect vector breeding sites. Now let's look at an example of how this may occur. In the pre-global warming era, cold temperatures, especially freezing at higher elevations, basically kept the vectors out of those areas. So that when a vector was not present at the higher elevations, the disease could not occur. But with increased warmth, some vectors have found higher elevation areas more hospitable. So when the vectors begin to thrive at higher elevations, the diseases correspondingly follow. And so it's important to remember that it's not really altitude that affects a vector-borne disease. It's more the average temperatures that, when they're higher, can support the growth and thriving of that vector. So pathogens such as malaria, schistosomiasis, and dengue are highly or very likely to be affected by climate change, and others such as filariasis, leishmaniasis, and arboviral diseases such as yellow fever or Japanese encephalitis are likely also to be influenced. Even though forecasting of the effects of global warming is imprecise, there are already examples of how this relationship with disease vectors is already occurring. And I'll give you this example. This is Antonio Ciano, a 62-year-old retiree from a place called Castiglione di Cervia near Ravenna in northern Italy. Now, in August of 2007, he inexplicably developed fever, malaise, and excruciating bone pain. And moreover, by mid-month, about 100 other people in the same town had developed the same malady. Now, Antonio was so weak at one point that he was quoted to say, "I simply couldn't stand up or get out of the car." Now, people blamed their government, they blamed the weather, and they said, well, there's a lot of recent immigrants coming into our town from Africa. Perhaps they brought some contagious pathogen. And so there was an exhaustive investigation by public health authorities. And ultimately, they discovered that they were right about the immigrants. But they were not human immigrants. They were mosquito immigrants. In fact, the Asian tiger mosquito that had spread to that area of Europe and had begun to thrive in that portion of Italy. Now, public health authorities in fact found that the individuals were suffering from a tropical disease called Chikungunya fever. And as you all know, this is a variant of dengue fever, which is usually endemic to the Indian Ocean region. But the mosquitoes found that they could thrive in a warming Europe and brought Chikungunya fever with them. Now, though the Asian tiger mosquito had first come to northern Italy about a decade ago, it's thought in a shipment of tires from Albania. Until recently, the temperatures had not been able to support the large populations of the mosquitoes. And this outbreak proved that if a tropical disease could flourish in as much of an out-of-the-way place as Castiglione, there's no reason that it could not thrive in many other places in Italy or Europe for that matter. And this was the first case of an epidemic of a tropical disease in a developed European country. Very interesting. So there's no question, too, that if we can see tropical Chikungunya fever extended to places in northern Europe, malaria is also likely to be significantly affected by climate change. In fact, climate factors are considered the most important cause of epidemic outbreaks of malaria in non-endemic areas. Now, an often cited example of the emergence of a disease vector in a non-endemic area is in the city of Nairobi, Kenya. Now, Nairobi is the capital and the largest city in Kenya, with a population of between 3 and 4 million people. And Kenya is at an elevation of 5,400 feet above sea level, and over the last several decades has been previously renowned as being malaria-free. Now, in order to have malaria transmission, 3 factors are necessary. You need to have the Plasmodium parasite, the Anopheles mosquito, shown here, and the human host. And although temperature extremes kill Anopheles, higher temperatures increase their rate of development. And this again goes back to the fact that altitude is not the limiting factor in malaria transmission. The actual limiting factor is the effect of a lower temperature on the parasite. Now, in Kenya's western highlands, maximum annual temperatures over the last 20 years are up about 1.8 degrees. And in the early 1990s, if a local doctor came across a case of malaria, it almost always involved a person who had traveled to the lowlands. But in recent years, scientists and health officials have repeatedly confirmed that Anopheles mosquitoes are working their way up the slopes of Mount Kenya, thriving at higher altitudes than ever before. Now, there are likely to be several factors for this, not just climate change, but climate change, I think, is at the heart of it all, because without the warmer temperatures, you simply wouldn't have the mosquito present in that environment, and without the vector, there would be no malaria. Now, dengue fever is also likely to follow its cousin chikungunya fever to areas previously inhospitable to its growth. Many of them, again, in some of the Andes regions of South America, which have previously not been able to support the mosquito vector. So it's been estimated that a 2 degrees Celsius rise in temperatures by the end of the 21st century could result in a 2.5-fold increase in dengue for most of South America. And this is concerning, of course, when you realize that 78% of the population in Latin America live in urban areas. Dengue fever likes urban areas, and so there are likely to be many millions of people who are potentially going to be also susceptible to dengue fever if warming patterns continue. Now, what about infectious disease vectors closer to home? This is a map of Tropical Storm Faye from last year. As it crossed our state, it made a record-setting 4 landfalls in the process, and it dumped 3 or more feet of rain in certain areas of Florida. Now, climate change appears to be influencing vector-borne diseases in the U.S. as well. For example, there was an extreme record-breaking summer drought on the East Coast during the summer of 1999 when West Nile virus was first identified in the New York area. And outbreaks of malaria in New York and New Jersey in the early 1990s were attributed to exceptionally hot, humid weather that reduced the development time of malaria sporozoites. Now, climate change can often be an arbitrary force. It has no agenda where human disease is concerned. So some effects may be beneficial and others may not be as good. So here are some examples of that in North America. The Ixodes tick is influenced by land use, soil type, elevation, deer populations, and so forth. And so it's been estimated that tick-borne diseases such as Rocky Mountain spotted fever may decline in the southern U.S. because of the hot and dry conditions that may result. So this is an overall positive effect. How about mosquito-borne diseases? We know that sustained cold weather and frost kill adult mosquitoes, and if there are decreases in cold weather, this may increase mosquito populations. So even though mosquito longevity decreases at higher temperatures, viral transmission rates rise. So it's not really sure what the overall effect of this will be. Although some factors suggest it may result in an overall increase in mosquito populations. In general, increased humidity favors the growth of mosquitoes. So dengue virus incidence may vary depending upon which factor predominates in a given area. It's been thought that if the temperature goes up in the middle part of the U.S., there may be a shift in some encephalitis types, for example, and a decrease in others in the south. Rodent-borne diseases can be affected by climate change. How many of you remember reading about hantavirus pulmonary syndrome in the early 1990s? There was an extreme drought for a period of time, and then these extremely heavy rains followed. And when the heavy rains followed, there was an abundant tenfold increase in the deer mouse population. And shortly after that, there was an outbreak of hantavirus pulmonary syndrome. Similarly, leptospirosis is associated with heavy flooding, freshwater environments, and the effects of small animal activity in polluting the water. And so this may increase in areas with heavy flooding. So overall, decrease effect. So what is the annual estimated worldwide illness and deaths associated with climate change? About 150,000 deaths and approximately 5 million illnesses. Now, there may be an element of apathy and inevitability to climate change and its effects. We can't stop all of the public health effects of climate change, but I think there are several things that, as public health people, we need to do. We need to develop a greater capability to predict emerging infectious disease threats. We need to enhance our surveillance mechanisms to know exactly what's occurring. Many of the examples that I cite where climate was believed to affect infectious diseases, we knew about it after the fact. We need to better understand the relationships between climate, ecosystems, and human health, and hopefully that will be occurring now that we have better recognition of this phenomenon. And we can do something in our own lives, whether it be to recycle our plastics, our plastic bottles today, or to travel less, or just to get out that bicycle and ride in your neighborhood when you would otherwise drive. So there's a lot of stuff that we can do. Change our lights to compact fluorescent lights. I just discovered this weekend there are compact fluorescent lights that dim now. So if you have a dimmer, you can actually put in your compact fluorescent where you have to use an incandescent light before. So I'm going to close with this quote by Robert Green Ingersoll, who wrote, "In nature, there are neither rewards nor punishments. There are only consequences." And thank you all very much. Any questions? I guess you could maybe argue that the movie Inconvenient Truth is kind of out of date. It's 4 years old, but it is very interesting, and you could have easily missed it a few years ago. So if you want to learn more about this, or at least start asking yourself some questions, you can get another